next section of 7.5, we're going to be solving two-step equations. Some equations require two inverse operations for solving. When solving two-step equations, use a reverse order of operations. So in the steps, number one, you're going to add or subtract the constant term, and you're going to multiply or divide the variable term. So in simpler forms, when you have a two-step equation, the first thing you're going to do is take care of the constant term. So in this problem, in our example, 5x minus 6 equals negative 21, the constant term that we're going to take care of would be the negative 6. So we're going to add 6 to each side because, again, our goal is to isolate the variable. So now I have 5x is equal to negative 21 plus 6 is negative 15. So I dealt with a constant term. Now I'm going to divide each side by 5. X is going to be equal to negative 3. And before I move on or go to the next problem, I'm going to check. Negative 3 times a positive 5 is negative 15. So in our next example, A, we have 3x plus 14 equals negative 1. So in this example, we're going to do the inverse operation, so we're going to subtract 14 to each side. We have 3x is equal to negative 15. Then you're going to divide each side by 3. X is equal to negative 5. I'm going to go back and check. Negative 5 times a positive 3 is negative 15. In B, we have x divided by 2 minus 10 is equal to negative 10. We're going to add 10 to each side. X divided by 2 is equal to 0. Multiply each side by 2. X is equal to 0. Okay, we have two more examples. C and D. Again, move the constant term by either adding or subtracting. Then we are going to multiply or divide to the variable term on each one of these. Okay, so in C, we're going to subtract 16 from each side. Then I'm going to do the inverse operation to each side. So in this, again, we're going to move the constant term, take care of the constant term, so we're going to subtract 5/8 each side. So I have negative 3x is equal to negative 7/8 minus 5/8 will be negative 12/8. Okay, so now in this problem, I'm left with, I have negative 3x is equal to negative 12/8. So I'm going to, for teaching purposes, I'm going to divide each side by negative 3. So now I have negative 12/8 divided by negative 3. So negative 12/8 divided by negative 3, I'm going to then multiply times its reciprocal since I'm dividing with a fraction. Next, I'm going to simplify before I multiply. Now I have 4 times negative 1 is negative 4. Because I was dividing each side by 3, which means I'll multiply it times its reciprocal since I'm dividing with a fraction. So 4 times negative 1 is negative 4. And then I have 8 times 1 is 8. Then I'm going to simplify that. X is equal to negative 1/2. So before we went to the next problem, we noticed that we were dividing in our original problem negative 12/8 divided by negative 3. So a negative divided by a negative, we changed it to multiplication, so we were multiplying two negatives, and that's going to equal a positive. So our final answer is going to be a positive 1/2. And we only found that out by going back and checking. Okay? So again, we're using the same two steps on these next two problems. I'm going to pause the video and come back and check our answers. So in this example, we're going to subtract 72 from each side. So now we have negative 72 is equal to 4t. Divide each side by 4, positive 4. When you take negative 72 divided by 4, it's going to be a negative 18, which is equal to t. I'm going to go back and check. Negative 18 times a positive 4 is negative 72. Okay, we're going to notice on F that we're going to need to combine some like terms. So I'm going to take 17r, subtract 7r, so I have 10r left. Plus 5 is equal to negative 5. Now I'm going to subtract 5 from each side. 10r is equal to negative 10. Now I'm going to divide 10 by each side. R is equal to negative 1. So, again, we're going to combine like terms if we need to. Then we're going to move the constant term over. Then we're going to either multiply or divide with the variable term. Let's do a couple more. Here in G, we're going to be working with decimals. In H, we're going to be using the distributive property. So in G, again, I'm trying to isolate the variable. I'm trying to get A by itself. So my constant term is 2 9/10. So since it's an equation, I'm going to subtract 2 9/10 from each side. So with decimals, you need to line them up. Remember that. Excuse me. Is that to a 2? Now I have 2 5/10 is equal to 3a. Again, I'm trying to get the a by itself. So after I corrected it back to the correct bracket, 7 5/10 is equal to 3a. I'm going to divide each side by 3. You can come down. So now, when I divide 7 5/10 divided by 3, it's going to have 2 5/10 is equal to a. Circle that for the less confusion. Okay. Down on H, I'm noticing I'm going to have to simplify that. I can't solve it, but I'm going to have to simplify it using the distributive property. So again, using the distributive property, 5x plus 30 equals 15. 30 from each side. Minus 30 is negative 15. I'm going to divide each side by 5. Negative 3 times a positive 5 is negative 15. Now, I am actually this time going to pause the video, come back after I have I and J up there complete. So notice on each of these examples, we move the constant term over, then we either multiply or divide with the coefficient. J, we use the distributive property and use the same 2 steps. Always, always, always go back and check your signs since you're dealing with negatives and positives. We have 2 more examples. Going to pause them. Again, pay close attention to the signs. Okay, so in each of these examples, check your work. Our goal is to get the x or the m by itself and do the inverse operations. Now, you're going to have word problems with these. Notice the type of two-step equations you've been having. Let me go back. You've had a number with a coefficient, and then a constant, and then an answer. A number with a coefficient, a constant, and then an answer. So in word problems, we're going to have the same thing. We're going to have a constant term, a number with a coefficient, and an equals to. So on this problem, we're going to have a constant term, like we've been doing, a coefficient with a variable, and then the total amount. So we knew that the constant term would be $35 because that's how much the parts were. The parts were not going to change. What we were determining is how many hours. So we had 40x plus 35 is equal to 95. Your bicycle needed to be fixed. A mechanic charged $40 each hour of labor, and the new parts cost $35. The total cost of fixing the bike was $95. Write and solve an equation to find the number of hours it took the mechanic to fix the bike. So I did this backwards and read the equation, read the problem after I already started talking about it. So I've gone back. Now it's 40x because it was $40 for each hour, plus the $35 for the part, and his total bill was $95. So we did our two-step equations, and the total amount of hours for $95 work was 1.5 hours. Okay, this is a little dark, but on our next one, we have the amusement park. Charge is $8 for admission and $1.50 for each ride. You spent $30 at the park. Write and solve an equation to find out how many rides you went on. Again, you're going to have a total amount, a constant term, and then a coefficient. I'm going to pause it and come back and give you the answer. So in this problem, sorry about the darkness of it, we have $1.50 a ride, so it's going to be $1.50 times R, plus your $8, which is your admission fee, and you spent a total of $32. So my constant term is $8 because that's how much you had to pay to get in. You're going to subtract $8 from each side, so you will have $1.50. R is equal to 24. Again, to determine how many rides you could ride, you divide each side by $1.50, which is a total of 16 rides. So our final answer for this is 16 rides because we took $24 and divided it by $1.50. The screen is dark, but that is your final answer with the work attached to it. In our last word problem, you had $65 to spend on party favors. On the internet, you found visors that cost $6 each. The shipping and handling charge is $5 for the entire order. Write and solve an equation to find out how many visors you can buy. So we know that you have $65 to spend. So that's going to be the total amount that you can spend. And then you know that each visor costs $6, and you're trying to see how many visors that you can buy. And then you had a flat fee of $5, which is for the shipping charge. So again, now we have 6V, 6 times the visors you can buy, plus $5 shipping and handling, and you don't want to spend any more than $65. So we're going to do our two-step equations. V is equal to 10 visors.